Okay, so now let's continue to the question in front of us. A hydraulic powered lift supports two boxes, and then this powered lift support in total 1,600. So two boxes, one each of them is 800 newtons with the center of gravity in the middle of each boxes, right? So neglect the individual weight of those members. And the first question is to draw for free body diagram. So it's not that difficult actually. You just need to draw the four free body diagrams. So AEF, yeah. So let's draw one by one. It should be straightforward. Yeah, let me make it thicker. In E, you have a pin, and then here, actually, you can draw like this, right? Let's divide by 2. So this is the equivalent force due to the first box. This is due to the second box. So this is the, how you call it, the interface between those two boxes, and we assume they are like very, very close to each other. So, and each of them 800, yeah. Okay. And then at E, if you realize this one is two force member, so you can basically put it like FED directly. And then EB, also the hydraulic, is two force member. You can put it FEB, two force member. And at A, you have AX and AY. Okay, so this is for the first free body diagram. Now ABC, yeah, for the ABC. ABC is also pretty simple. So we put it like this. A, C, yeah, and then with a bit length here, and then you will have this reaction FEB2, yeah, and then at point A, because it's a pin joint, so you will have AX and AY, but make sure they are now with the opposite directions to this one, right? Because when they are assembled again, they should be disappear, right? So action reactions. And CX, CY, you will have CX, and then you will have CY. Okay, that's the second free how you call it, free body diagram for ABC. Now ED. ED is pretty simple, yeah. ED, let's draw it like this. Okay, since this will counter the free body diagram, this will be FED, and this, since this is a pin joint, you will have a DX, and let me make it same color. So this one will be DX, and this one will be DY, or in this case maybe DY. If you evaluate here, DY will be 0 because it's the only forces working in Y direction, while DX will be equals to FED, right? And then you will have this how you call it, let's draw it here, yeah. So from here to here, so you will have this hydraulic, and then you will have something like here, okay, and this will create FEB, counter this one, and then it will also have FEB, counter this one. So these are the whole free body diagram for all members, yeah. So we label all forces, and we make sure that the direction is correct, yeah. So they counter each other, so when they are assembled again, they will disappear, right? Okay, so now A is finished. We need to determine the force in the hydraulic actuator BE, yeah, BE or EB here. This is the guy in question. EB found first. So if you work with this, it's quite difficult maybe. So I suggest you to work. There's so many ways to solve things, right? But I think the easier way to do it is basically just to get the, and then you will give a CX, am I right? And then so let me make it pink color, CX, and then you will have a CY, is it okay? And then you will have this connected to here, right? Okay, and then this connected to here, right? So basically this one will generate dx and then dy, right? And then to simplify, let's put it here 800, here also 800. Okay, so let's assume the box is gone, replaced by this 800, right? That's it. I think that's it, right? Yeah, and then what you can do is, since we want to find the dx, yeah, we want to find the dx because here, if you see here, if you see these equations, let me draw. Sigma fx equals 0, your dx will be equals to FAD. So you need to find FAD and then you can get FAB. Anyway, so let's find the sigma moment at point C. Yeah, or maybe at point D, it's better. Yeah, sigma moment at point D is equals to 0, and then the CX, yes, so we're evaluating here, this will create 600, yeah, length moment, CX times 600, because it's counterclockwise, and then the CY will create 0 moment, because it's one line with respect to the center of the moment that we're evaluating. And then 800, and this 800 will create negative, right? Oh, positive, 800 times the distance from here to here, right? So from here, which is 300 times 600, 900, so 1800, I guess. 1800 plus 800 times this guy, I think it's 1500 times 900, 2400. Am I right? Yes, 2400. Go 0. So cancel, you got 3, you got 4, and then your CX will be equals to minus 5600. Yeah, and then you evaluate sigma fx equals 0, and then this will give you dx equals 5600. Yeah, because it's only cx and dx, so if it's one positive, one negative, this will be Newton and Newton, right? And then let's mark this as a green color. Okay, so once you have the cx and dx, easy, right? It means that if you evaluate here, your dx is FAD, yeah, FAD. So in this case, your FED will be equals 5602. And then this one, got it from here, from this free body diagram, okay? And then once you got that, you evaluate the L shape again. You can write it here, but let's rewrite again to make it clear. So there is 800, 800, and then here there is FAD, right? FAD, and then there is FAB, the force in the hydraulic that we want to find out, right? And then there is AY, and there's AX. Am I right? Yeah, X and Y. It's correct. And then how to find FAB? Simple, yeah, because you care only about this, and then it's better to take the moment at A, yeah. Sigma moment at A equals 0. All right, so AX and AY will create no moment. FAD will create moment. FAB will create moment, but only to the this one. That's yeah. So it has it has a vertical component and horizontal component. So the one that generates is this one, right? The horizontal one. So if you take the moment, it will be 5,000, 5,000, sorry, yeah, 5,600 times FAD, yeah, the distance from here to here, yeah, from here to here, it's 600. So, 600, and then your FAB will, and this will be negative because with respect to A, it will have clockwise, so it's negative, and then negative FAB, and then you need to project them into the horizontal component, which is this length divided by the diagonal. This length is 900 divided by the diagonal 900 and 600. So 900 divided by square root of 900 square plus 600 square. Yeah, and this is the projection time the distance from here to here, which is also 600, right? 600, and then there will be counterclockwise moment due to 800 and 800, so plus 800 times 300, I guess. Yeah, 300 this distance, right? 300 plus 800 times this distance, adding 600, so it's total 900, and they become 0, I guess. So if we divide by 300, this cancels, so it becomes 3, it becomes 2, and this becomes 2. Yeah, this will become minus 11,200 minus FAB times 1800 divided by square root of 900 plus 600 square, and then this will become 800, 3,200 equals 0. It means that your FAB moved to the right, minus 1102, so it will become minus, let me check my calculator, around something here. Okay, and this is in Newton, I guess, right? In Newton. Okay, so this is the force in hydraulic, and if you see here, FAB is minus, so basically the hydraulic will be in compression. Yeah, the hydraulic cylinder will be in compression. Okay, so that's it. Not that difficult, right? So this is important. This is what you need to find. You need to be able to make sure that when you disassemble, the labeling of the forces and the direction is correct, making sure that they are following the action and reaction law. And then after that, you try to solve for the simplest one here. If you realize here, I start with the global free body diagram first. I get a CX and DX. Once I get that, I get to the local one. Here, I get the understanding that the dx is equal to FAD. Once I get that, I go to this L-shaped structure, and then I calculate moment at point A. FAD already known, previous calculation, and then I can get the FAB. But when I taking the moment, the FAB, because it has some angle, this angle will create a vertical components, which with respect to A will not generate any moment, but the horizontal component of FEB will create moment with distance of 600, I guess. Yeah, the one that I have here. And then when calculating, it's just arithmetics. you can get that the FEB is minus 5780 newtons. So it means that since it's minus, it's compression. Okay. And then what's next? Draw the bending moment diagram for ABC. I will not solve for this, but the idea is that if you want to solve this, making sure that your FAB, now the forces is reversed, right? You have AY, and then you have AX, and then you will have this FEB, and then you will have what else? CX and CY, yeah? CX and CY. Okay, CX you already known previously. What is the value of CX? Minus 5,600, yeah? Minus 5,600 Newton. The value of CY unknown yet. And then FEB, you know that it's minus 5780 Newton. So you have three unknowns. It's very simple. I will not solve this for you, but I will get sigma moment at A equals 0. You will get CY, yeah? Once you get the CY, you can get the sigma Fx equals 0. You will get AX. And then sigma Fy equals 0. You have AY. Okay? Once you get that, you see, all of them are typical concentrated load. Basically, what you need to do is cutting once here and cutting once here. So if you cut the left side, this will become AX, AY, and this distance will be X. And then here, you will have V, the shear force, internal shear force, internal normal force, and then moment. Okay? And then you can calculate using the same equation again. Sigma moment equals 0, sigma Fx equals 0, sigma Fy equals 0. And then you can plot it. And then again, if you want to take the right side, and this will become Cx, and then this will become Cy, right? And if we call it X, this one will be, how much is the length of this guy? 1500, yeah? So this will be 1500 minus X, because this one is X, this one will be minus 1500 minus X. But then he will have this V, N, and then you get M, right? And then you can plot it as you want. Okay? Will not be good. It will not be difficult. I will leave it for you to practice and let me know the answer for AX, AY, and then for CY in the comment section below. And then give me also the value of V and M for first section and second section, so people can check your answer in the video, right? Thank you very much, and I hope it's clear enough. Yeah, so don't be panic when you see this kind of things. Try to, you see, the most challenging part is that you need to realize that this shape is a two force member. So you need to think, because the force only working at those ends. Yeah, there's nothing for, if imagine the question is changed, that there is a force working like this, it is not three force member, it's not two force member. Yeah, so when you disassemble this, in this E you have EX, EY, and also the force EB. Yeah, but in this case, since this is a two force member, because there is no force acting on this part, even though the shape it's like this, yeah, it's still two force member because there is no force acting on it. Yeah, no force. So the force only acting at those endpoints. Yeah, so you can assume them as a two force member. So basically, you can just, when you draw the free body diagram, you can replace it. When you replace the structure with the force, just change it, replace with a force like this, from endpoint to another endpoint. Not like this, yeah? Not like this. This is wrong, okay? Okay, I hope it's clear enough for you guys. So make sure you practice for the next exam. Bye.